This is Fake, an almost perfect 3D reconstruction made from a handful of 2D images. And it's one of the many cutting-edge technologies we'll be going over in this video that will forever change the gaming industry. From groundbreaking graphics techniques that leave ray tracing in the dust, to playing games using only your thoughts, will these technologies change the industry for the better or lead it to a doomed fate? Have you ever walked outside and thought, this would be kind of cool in a video game? Well, what if I told you with this brand new technology, you could put any place in the world into a video game in less than 1 hour? It has a name, and it's called triangle splatting. Just look at some of the examples made by the team behind the tech. This is running at 2400 FPS at 1280p, and you can pretty much see most of the tiny details in extraordinary quality, which will make it possible to make photorealistic games easier than ever with only a fraction of the cost. It's free. Take my money! But to understand how it will change the gaming industry forever, we need to take a look at its grandfather, Nerf. Not that kind. I wish I had one to show you. Short for neural radiance field. With Nerf, you'd take a ton of images of the space you want to 3D-ify and then feed it into a neural network, and it would learn how the light behaves in the scene from every possible angle. Now, it's a great idea, but the only problem was you'd need a lot of images, and it was super slow to train. It kind of feels like trying to 3D print a photo, one photon at a time. It's also not great for video games, which is what this video is about, since you can't really interact with the scene you generate. But hope was not all lost, because some researchers decided to iterate on it and came up with its child, Gaussian splatting. This method similarly uses images to construct the scene, but instead of a neural network, it uses a bunch of 3D points called Gaussians, kind of like a 3D point cloud. Each of these points stores data about their position, size, light, and transparency. Then they're basically pasted on top of each other in layers to create a 3D scene. Now, you could render any realistic scene in real time instead of previously having your computer run for hours just to be able to rotate your head around a hot dog. It looks cool though. But the newest edition, triangle splatting, takes this one step forwards, and it's highly likely that it's going to be the main method to make realistic environments going forwards. What it does is take what the GPU is already good at, triangles, the backbone of game development, and uses those instead of points. Simple, right? Well, this leads to way better reflections and more details while running 100 times faster. But while these fancy splatting technologies give us nice environments faster than ever, what about real-time lighting for those environments? Lighting can make or break a game, and the next technology on the list puts ray tracing to shame. Normally with video games, you'd use tricks and approximations to make lighting appear as realistic as possible. Even shadows are usually just blobs or straight up up. But if you're lucky enough to have an RTX 9000 5090, you can run a game with ray tracing, which simulates how light behaves in real life by bouncing a ray off a light source until it hits a wall or another light source, kind of like a ricochet laser pointer. Now, path tracing does this, but on steroids. Instead of just one ray, it bounces multiple rays off per pixel and keeps bouncing them around the scene, taking into account scattering and reflections, which ends up equating to almost cinematic realism. And graphics aren't the only thing that can be path or ray traced. We're just now seeing the rise of ray traced audio in games, where the sound behaves just like light. Instead of bouncing light rays off surfaces, it simulates how sound waves reflect and scatter throughout the space. This means you'll be able to accurately hear footsteps echoing or listen to different gunshot sounds based on what room you're in. And they're just starting to experiment with path-traced audio, where the rays will keep bouncing around the environment, giving even richer sounding audio. Unfortunately, there is a reason you don't see path tracing used much in games, and that's because it's very intense to run on most computers. It's mainly used for offline rendering for movies or visual effects. But some games like Cyberpunk 2077 add in an RT overdrive mode that lets you try an experimental path tracing. Researchers are looking into ways to make these technologies faster to implement in real-time games, but there's already a few shortcuts they use that they're rapidly developing, and you've probably used one of them without realizing. DLSS, or deep learning super sampling, which is a little bit of a mouthful, but has been used for years in most AAA games to upscale low-resolution frames to higher ones in real time. However, they've taken it one step further with the introduction of NVIDIA's DLSS 4, which everyone loves. With it, they added frame generation. So now it hallucinates and adds in frames in between the other ones, so it can appear that the game is running smoother than before at a higher FPS. And it only starts at $300. Because the AI magically improves performance at a fraction of the cost. They also added ray reconstruction in DLSS 3.5. which also uses AI to essentially reconstruct ray tracing lighting. So at this point, do game developers even need to make lighting look good during development if AI will do all the work later? But more seriously, a big issue with these neural models is noise. But everyday engineers are working tirelessly to make these models amazing and have less noise, and soon we won't be able to distinguish what's a real frame and a made-up frame, which will lead to a better looking game and a higher FPS. Theoretically. On the other hand, there's a technology that already better simulates lighting, and you can actually use it right now. Radiance Cascades are a super new developing technology. Instead of calculating every light bounce from scratch, like in ray or path tracing, it instead uses a clever trick. It saves snapshots of how light behaves at different distances, and then reuses that data across frames. So when something in the scene changes, like the sun moves or you walk into a dark room, the lighting reacts immediately with little to no loss in performance. It's essentially giving global illumination a memory, and when combined with other tech, like ray-traced audio or dynamic shadows, you start to enter a world that doesn't just look, but feels real. Now, graphics are cool and everything, but we know that graphics isn't everything in a game. Some of the best game experiences have mid graphics. No offense. Instead, these games focus on how you interact with the world and how the world interacts with you. I made a video a while ago about GTA 6 and their crazy new patent, where they came up with a new way to not just animate NPCs, but to have them respond to you more realistically. Very basically, they do this by taking into account each NPC's mood, the weather, the player's actions, and the world around them. The NPCs then blend multiple actions for different body parts on the fly to reflect their current attitude or reaction. You can watch the full video on my channel for more details. Now, it's no secret that GTA 6 has taken a long time, and that systems like these are insanely difficult to make. But what if you took a system like that and combined it with the power of AI chatbots like ChatGPT? Pretty soon you'll be able to directly chat with most characters in your favorite games using your voice, and have them respond back to you with their AI generated voice, and have the world change depending on your actions and what you say. There's already a few examples of this that have gone viral, but right now it's far too inefficient to use them in games. You can't run a good language model quickly and locally without it using a ton of space. And if you use an online service, either you'll have to pay for it or you'll have to make the user pay for it, or the player. And no gamer is gonna go out of their way to go to Open API, open up an account, put in their credit card information, get the API key, and then put it in your game. Well, most gamers won't do that. Even just downloading and installing Ubisoft for Steam games leads to negative reviews. But AI models are getting cheaper and faster every day. So it's not too far into the future when you'll be able to run a great language model locally, even on your phone. Now, we still have a lot of weird and fascinating technologies to discuss, but there's one big thing the game industry cannot live without before all of these. Money. Money, money, money. Studios and AAA companies need to not only make money, but make a lot of money. Even big studios are constantly getting dropped by publishers if things don't align financially. And while there are a lot of ways to monetize games, unfortunately they're all kind of complicated and require a lot of work. Don't even get me started on international payments. But there is a new system that is the future of the gaming economy, and that a lot of companies are already using to handle selling in-game items. It's called Web Shop, and it's made by Xsolla, the sponsor of this video. It's essentially a custom storefront for your game, where players can buy items, currency, and top up their accounts directly, without the 30% platform tax most existing services take. Xsolla, on the other hand, only takes 5%. Now, Web Shop was made for mobile games in mind, which is currently the largest sector of the gaming industry because of how easy it is to access. But it does work on PC. Players can easily log in via mobile game, or use a huge list of login providers, and the setup is dead simple. You just paste in the link to your app and boom, you have access to bundles, targeted offers, discounts, in-game bonuses, reward system, and promotional events. They accept over 1,000 payment methods, which is actually insane. It lets developers easily publish their store pages to anywhere in the world without having to worry about currencies, which is always a hassle to deal with, trust me. Check out Xsolla Web Shop down in the description. It could be the most profitable decision you make this year. Now, this next technology is mind-blowing. There's a streamer called Perry Cariel. I probably butchered that. Went viral for doing something no one thought was possible. She beat Elden Ring with her brain. Which is insane, because Elden Ring is hard with a controller. So how exactly was she able to do that? Well, she used a device called an EEG to transmit signals from her brain into the game, triggering in-game actions. Now, normally these devices aren't made for super complicated actions. They're mostly used in research for one. But Perry Carriel somehow managed to play Valorant, Warhammer, and more only using EEG signals. But you do see that she has to focus super intently to do pretty much everything, which I feel like that might give me a headache. But soon we'll be able to play games without having to use our hands at all, which is great for people to have easier access to video games like people with disabilities. Just last year, someone used a Neuralink to play Counter-Strike just with his brain. I wouldn't trust having a Neuralink in my noggin, though. Now imagine not only controlling the game with your brain, but also feeling it. Haptics are usually simply known as controller rumbling, which helps immerse the player in the gaming experience. But now we have a ton of weird wearables that simulates how it actually feels like to be in the game. From haptic vests for VR, which lets you feel gunshots, weather, gloves that simulate grabbing objects, treadmills that let you run in place while you escape a zombie apocalypse, or now technology that lets you smell the poop in the street while you pass it in the game. Riveting, but this is only the start. Researchers are already building next-gen wearables that can mimic the complexity of human touch. They have these tiny sensors that detect pressure, vibration, and stretching, and then apply force in different directions on your skin to simulate things like grabbing, squeezing, brushing, or even textures. Whether or not this will end up being a good thing remains to be seen. Now we get into some technologies that are controversial, to say the least. Prompt engineering is where you basically guide an AI by chatting and directing it into making something for you. Kind of like the Boy Scouts. You're the leader telling the Boy Scouts what to do, and they do all the work for you. But in this case, it's an AI. It's an incredibly fast-growing field, and recently a Twitter user with little game development experience called Level CO completely vibe-coded an online web-based airplane game and even received a good amount of money by offering companies ad placement in-game. Smart. Now, I do think this project was a little overhyped, I'm not gonna lie, because there's a lot of amazing games out there that don't even get 10% of the traction that this got. But it just goes to show how impactful AI is and that a lot of people want to learn it since it lets them do stuff that they couldn't do before. But the technology definitely isn't perfect. Far from it. In my case, I use ChatGPT and Copilot, which runs in my code editor to help me out while I'm coding if I'm stuck or just don't want to write something super repetitive. But it's definitely been wrong a lot of times, and it leads me down the wrong path too. So I would definitely take what it says at face value and just research the stuff before you trust it completely. It is a little worrying though for new developers that just don't do that. I mean, we've already been seeing people graduate from college having depended on ChatGPT the whole way around. And since the job market is already brutal and is not really hiring any entry-level developers, I can only see the industry continuing to dip if changes are not made or if people are not adapting. On a lighter note, there's already a few companies working on tools to make game development easier. Unity has a newish product called Muse, where you just describe what you want and it uses AI to start building a simple scene for you. And then on the flip side, there's Unreal Engine with a tool called PCG, or Procedural Content Generation, which procedurally fills in the gaps of your world or terrain with incredible detail. Now this isn't AI, but it essentially does the same amount of work one would do, or more. And with this, artists don't need to spend days placing every rock or tree in their MMORPGs. Combine this with prompting and it'll be easier than ever to create massive open worlds that adapt to the player. It's still early, but there will definitely be a moment in the future where you'll be able to make a game without knowing how to write a single line of code. And no, I'm not talking about Unreal Engine's blueprints. That doesn't count. That said, if you're serious about making games, then learning how to code, or learning how logic works at least, is a must. And I've made a full video giving you the blueprint on how to start your game development journey in the description. But there's even more groundbreaking technologies that are getting improved vastly every single day that will either make or break the gaming industry. These following ones promise to replace a lot of manual work, starting with AI-generated 3D models. It works by typing in a prompt and maybe including an image or a sketch, and it'll spit out a 3D model. In just a year, they've managed to increase the quality of the generation by tenfold, which opens up a lot of possibilities for indie developers or People just want to make 3D models of their cats. Even for existing 3D modelers, having a solid base to work off of would dramatically improve their productivity and lead to faster iteration. But there is a huge issue with most of these products right now, and it's that they pretty much suck. The models are smudged, the poly counts are insane, and the UV unwrapping looks like it's been done by a 5-year-old, pretty much making them impossible to use in any good game. Ironically, UV unwrapping, one of the most time-consuming parts of 3D art, and something artists would want a tool for to make life easier, has barely received any attention compared to turning a text into a 3D thing. And it seems like a lot of the AI industry is hell-bent on replacing rather than supplementing, which is why it's such a controversial issue and why a lot of artists don't like it, since it's targeting the creative parts of making and not the tedious parts, like UV unwrapping. At this rate, I think it's going to be another year or two before we see a decent workflow going from AI text to 3D, unwrapping it, and rigging and animating them with AI. Bypassing the need to spend hours learning how to even navigate the maze that is Blender to be able to rig a simple 3D model. Essentially, rigging takes a 3D model and gives it a skeleton, so you can add animations to it. And a good rig is a must if you want to have not jank animations. Tools like Mixamo and AutoRig Pro for Blender have made this easier for years already, but once you start straying away from humans and get into the dragons, spiders, and weird creatures, rigging starts to get a little more complicated. And that's where tools like anything.world promise a solution. An AI rigging tool which seems like it can rig anything, to a certain degree of quality, of course. But rigging is only half, well, 25% of the battle, since the actual animations themselves can be the difference between your game being praised or being considered slop. Animations are notoriously hard to make. You need to be able to capture the emotion, the timing, the personality, and take into account every player's potential move. Unless you're a seasoned animator, it's very hard to make even decent ones. But there's already a solution for this. Cascadeur, I don't know, uses AI-assisted keyframing to help you keyframe poses that follow the laws of physics. Even Unreal Engine has been making incredible strides at improving their animation system in 5.5 and above by using control rigs and inverse kinematic tools to help you easily animate completely inside the engine. But this video is about emerging technologies, not the ones that are already out, obviously. The real future of animation will come down to two things: prompting and video. Prompt animation tools already exist. Unity Muse is working on a product that does just this, and although it's still wonky and needs a lot of post cleanup, it's a great first step into making animation as easy as typing a sentence. Then there's video to animation, which I think is more promising and accurate so far, which turns any person's movement in a video into an animation without needing the $1,000 setup of a traditional mocap studio or the pricey mocap suit. But all of these animations and 3D models take up space on your computer. And we all know the struggle of having to download 100GB games constantly. But these next two technologies quietly change how games are made and delivered, which might actually be the most revolutionary technology for the gaming industry rather than all these flashy ones. Normally, game developers use a ton of tricks to achieve better performance and lower download sizes, like lowering texture resolution, compressing the audio until it sounds like a toaster, using texture atlases to pack images together to take less space, and even virtual texturing to split large textures into tiles and stream the data to the GPU. Now, these methods usually lead to lower quality graphics and audio. Neural compression, on the other hand, uses machine learning to find smarter ways to store the data. And this goes for any asset, animation, model, environment, which leads to lower download sizes and overall better performance. NVIDIA is already working on a few of these, like RTX Neural Texture Compression and Neural VDB, which uses AI to compress the size of VDBs, which are mostly used in film to simulate large explosions and complex particle effects. We haven't seen them much in games though, because they take up so much space. Just one VDB can easily be 60 to 80 gigabytes. So you'd easily need a few terabytes just to run one shooting game at that point. But this technology opens up the possibility of huge cinematic and adaptable open world games, with potentially even smaller download sizes than current games. On the flip side, USD, not dollars, but universal scene description isn't exactly a new technology or the flashiest, but it's just now starting to get widely used in video games, and it's kind of a big deal. It's a file format. But not just any file format. It's quickly becoming the standard for storing and sharing everything in a 3D scene. Animations, rigs, textures, and what makes it so powerful is that it's made to be shared with others. As a game developer, it's literally such a hassle to have a million 3D file types to have to deal with. OBJ, FBX, Blender. Sometimes you need to install an add-on just to support that file type in an engine, and good luck configuring it if it doesn't work. With USD, however, multiple people can work on the same scene at the same time without overwriting each other's work and use the same file format. USD is also non-destructive, so you can layer changes like adjusting materials or adding an animation without touching the original or breaking file, almost like a version control system. So while not flashy, when combined with neural compression, it'll be an incredible game changer for the gaming industry. And it's set to be the main file format for games going forwards. And if you're wondering how exactly USD looks like in action, NVIDIA's RTX Remix is one of the best real-world examples. Modding has always been painful. If the game didn't support it outright, you'd have to reverse engineer the game files to change even the simplest texture. Even upgrading the lighting or adding models could take weeks, and you'd be bound to the technology they used in the game, unless you spent an obscene amount of time upgrading it. RTX Remix changes that. It uses AI to allow modders to take old school games and completely overhaul them using generative AI, ray tracing, and neural rendering technology. It can do that by capturing a game while it's running and then converting the entire scene into the USD file format. From there, you can drop it into other tools like Omniverse, also by NVIDIA, or Blender, and easily upgrade it. Then, once you're done, Remix injects your changes back into the game, and suddenly the original Half-Life games looks like it was made in the past couple of years. And honestly, this is just scratching the surface. There's so much more insane tech coming out, and we're only just at the beginning. While a lot of it is extremely promising and will open up game development to the average Joe, it will probably also lead to the gaming industry being flooded with AI slop and half-assed games with poor performance. The best way to reign on top of all those games, though, is to actually know what you're doing and be intentional about your use of the tools. And if that sounds like you, you should really check out my video on learning how to make your own game. And you should get the desktop game I recently released to help keep you company while you learn. Link in description. Hasta la vista.